Columbia, Houston, if you concur, we'll bring TV down in 10 seconds.
I concur. Let me know when I'm live.
Bob, we're live on the flight deck.
Good afternoon. 25 years ago, at this moment, Neil Armstrong stepped down on the surface of the moon. This was the first time in history that humans had reached another celestial body. It was an event that brought all people of all nations together in a common spirit at one time. We are extremely proud to be in space this time aboard the Space Shuttle Columbia, the namesake of the command module that carried Neil, Buzz Aldrin, and Mike Collins to the moon 25 years ago. We hope with sincerity that one step that Neil took back then will become a giant leap for people of vision as we press on towards the International Space Station and beyond. We would also like to send our sincere best wishes and greetings to the nearly 2,000 people gathered to celebrate this event at the Astro Hall in Houston, Texas. We acknowledge the distinguished guests, and although we can't be with you, we're with you in spirit, and we're glad to be airborne in space at this time during this special event. Thank you. And if you're still with me, Houston, I'd like to switch to the mid-deck camera, and I'll give you a little science summary of what we've done in the last 24 hours.
Great, Bob. We're ready.
Well, first off, we had a little spare time after the Blue Guys, or before the Blue Guys went to bed, and I was going to demonstrate a couple things for them that you can only see in space, or I've only seen them in space. There's a common needle-nose pliers twirling, a little physics lesson here. And notice that when you open that up, every 1.5 turns, it swaps ends 180 degrees.
And Bob,
I'll let somebody back on Earth in one of their physics classes figure that one out.
Break, Bob, we're getting an unsteady image right now. I don't know if we need to restart the camcorder or not.
Okay,
it's
steady
looking
for me. Let me rewind it and start it again.
It's looking good now. It'd be your call whether you want to rewind it or not. And we do have the time to do that.
Well, if you don't mind watching a rewind, I'll zip back to the beginning.
That'll be great.
Okay, here's the needle-nose pliers out of the IFM kit. How's that?
That's great, Bob.
Well, you saw it spinning with it closed, but if you open it up and spin it the same way, every 1.5 turns, it'll swap ends 180 degrees. I haven't quite figured that one out. Now this, I'm showing water here, two bubbles floating next to each other, globules of water, and it's an interesting property that liquids have in microgravity. The surface tension holds them together. You saw two bubbles join there into one. Here again, two bubbles, you'll see the surface tension, they actually bounce off each other and not join. Now, we've been doing a lot of floating of liquids back in Tempest, metals, and one of the properties that we're looking at is how we can make metals in a microgravity environment. We can do this on Earth, containerless processing, but it requires very high currents, and the heat causes the metal not to form the same as it does on Earth in space without that. So that was that demonstration. I should have had a little more time to explain. This is just the conservation of angular momentum. You can see Leroy spinning as he throws his arms out. He almost comes to a complete stop, but then resumes the rotation. Carl thought that was pretty neat, so he wanted to give it a try. And if he didn't bump into anything and I could spin him just perfectly free there in a frictionless environment, he'd just keep on spinning. I put this in for all the incos. This is our KU antenna that we use for communication between the orbiter for all our data I think Jim Halsell recorded that. He's been enamored with watching it during its gimbal repositioning. Back in the lab, Chiaki is working with Nizimi. This is a German Space Agency experiment, and it's a rotating microscope. The microscope's in a centrifuge inside there, and it produces various G levels. And they're studying various plant and animal life inside there at microgravity as well as 1G, and to see what the different effects are. Right now, Chiaki has loaded a sample of Euglena in there. Euglena is a plant, but you can actually see it swimming around inside there. It does move. And I'll show you what those test chambers look like that she loaded in there. That's the test chamber with various samples in it. And here you can see the microscope rotating inside, establishing that's less than 1G that it's rotating at right now. The Euglena tend to swim away from the G vector. Rick is working with the Bubble Drop and Particle Unit, BDPU, provided by ESA, the European Space Agency. He's getting ready to unload one sample and move in another. BDPU is looking at the dynamics of bubbles and drops under non-uniform thermal conditions. And it looks at interaction between how convection affects the bubbles. Basically what we're trying to do here is just learn how fluids act in a microgravity environment so we can eventually build, for example, ball bearings that would be completely frictionless. Once we learn how metals behave in a microgravity environment, there's probably going to be some very exotic alloys that can be manufactured. And this couples along with Tempest. Once we learn how the liquids behave, then we can also work with them in the containerless processing. Rick's just showing the different samples. Notice that cannon plug he took out of there. Each one of those connectors, this is like a mini laboratory all of its own as far as the tests that it can run on the various samples. Rick's loading the film in the camera now after loading in the new sample in BDPU. And I'm always showing you the inside of the lab. I thought it was about time folks saw what it looked like from the outside. It's just a pretty day over the Pacific Ocean there, and the lab and orbiter are looking fantastic. This is crossing the east coast of South America. That one point, the second point down, is Rio de Janeiro, and it looked like a beautiful day in Rio, and just really nice out there. And I showed this before. This is the Medaka in their chamber, and I just wanted you to see the chamber again with the Medaka swimming around because we had a new event. Here you can see some of the embryo developing the fish eggs, but as you scan around in there, if you notice off to the side, there's a baby Medaka in there, fish fry. So we had a birth in the last 24 hours, a new event on board. A little dark up here as we went into darkness, and but I brought some more folks up because we all wanted to say hi on this special occasion, the 20th 25th anniversary of landing on the moon. I know we got guys that it really meant a lot to them. John Thomas, for one, is a real Apollo 11 buff. I think just about any question I want to know about Apollo, I can ask Don, and he's got the answer. And I don't know, anybody else got anything they want to say while we're all up here? It's not often we all get together. We've been awful busy. Things are starting to wind down in the lab, and it's been just a super flight. I can't, again, I said it this morning at the press conference, I'm really proud of these guys. They have worked extremely hard, just done an outstanding job. It's a culmination of a lot of years of hard work, and I couldn't be happier with the results.
Speaking from the, I guess the payload side of the crew, you know, we've spent the last couple of years together with hundreds of scientists and payload teams all over the world, and it's been a tremendous amount of fun developing the mission and now flying the mission for those people, being their hands in space. I can't tell you how much fun it's been to do that, and I also can't say how much I appreciate the tremendous teamwork that we built up over the last couple of years, and it showed on this flight. We were enjoying it in the IFM, the last one we did that got FFEU going. Chiaki and I were talking to each other about the fact that we had some pieces from Biorac, part of ESA in Europe, and some pieces from the U.S. space equipment here on the orbiter to help repair the Japanese equipment, FFEU. And that teamwork is just, that's what this is all about to me. That's what makes the space program work, and that's why it's so much fun to do. I don't know of anything like this where we all get together and can so well agree on a common goal of conducting space flight together, and I think that's why the International Space Station is going to be a resounding success and good for everybody in the world, because together we can do something that we can't do individually, and this mission is just one example of that, but it's been a lot of fun to be part of it.
Well, with that, I guess we'll close for this evening. I gave you a different view of the orbiter. As you notice, we're sitting on the forward flight deck tonight, and that's because we're turning this mini space station into a piloted spacecraft again as we get ready for entry and shift gears on board in mental thinking, at least Jim and I. Jim finally got to do a maneuver. He was so pleased to be a real space pilot, so he's really happy. We'll close with that, and I'd just like to say happy 25th anniversary to all the folks celebrating the Apollo landing. It was a significant event, and we're going to continue to press on and do well and even do better. Thank you all.
And thanks, Bob. And we certainly wholeheartedly down here feel that the work that you folks have done have really made this an appropriate 25th commemoration. You really put in perspective what those guys did 25 years ago and show that we're not just going into space for the trip now, but we're going up there for some serious science.
They might have had a little more glamorous journey than we have, but I think our accommodations are a little better than what they had in that Apollo capsule.
Thanks, Bob. We couldn't agree more. From the Orbit 2 team, we'd like to bid you good night. We'll talk to you tomorrow and be ready to really change our orientation to bringing you home. And it's really great to see the whole crew up there, since we haven't had a chance to see much of the blue team. And for the four of you on board, go Hairballs. And Bob will be handing over to Story and that team.
Okay.
And Columbia, we're on the flight deck with you.
Roger that story, and we're ready whenever you are down there.
Yes, sir, we're ready.
Okay. Well, 25 years ago at this moment, Neil Armstrong became the first person to step on another world. His footprints and those of Buzz Aldrin remain at the Sea of Tranquility today as a tribute to a journey fueled by the imagination of humans. This occasion was unique in human history, the fulfillment of one of humanity's oldest desires, to explore to the limits and then to go beyond. It buoyed the spirit of the entire world. Today, the crew of the shuttle Columbia is taking its own small step tonight toward the establishment of a permanent human presence in space with our scientific research. We hope that our research, the research and activities of other shuttle missions, and the International Space Station will continue to buoy up the human spirit and capture the imagination of this generation and generations to come. We are honored to participate in this historic anniversary and extend our greetings to all those back on Earth participating in the remembrance of one of the greatest moments in human history.
Thanks very much, STS-65. You formed a very important bridge between the glorious history of the Apollo lunar landing and our future in space. Your perspective has enhanced our appreciation of this event. Thank you very much.
Thank you, Story. Thomas would like to say something real quick.
And Story, to all the great people working down in the Mission Control Center tonight, we just want to extend our appreciation. The Apollo 11 moonwalk would never have been possible without the dedicated efforts of thousands of people back there at the Mission Control Center, and we had the same dedicated, high-quality people working in there tonight during our shift and during our entire mission here. So from the entire Blue Shift, just thanks a lot for all your hard work during our mission. Really appreciate all the support.
And Phil and the team genuinely appreciate the thanks, Don.
Very few events are embedded into the national memory as firmly as the one we're celebrating tonight. At 9:56 p.m. Central Time on July 20th, 1969, Neil Armstrong set foot on the moon and uttered the words that are now part of our national heritage. The National Aeronautics and Space Administration would now like to share the sights and sounds of that historic moment 25 years ago.
Roger, TV circuit breakers in. Race 5 clear.
Roger. And we're getting a picture on the TV.
Okay. You got a good picture, huh?
There's a great deal of contrast in it, and currently it's upside down on our monitor, but we can make out a fair amount of detail.
Okay, would you verify the position the opening I ought to have on the camera?
Stand by. Okay, Neil, we can see you coming down the ladder now.
Okay, Neil, we can see you coming. Okay, I just checked getting back up to that first step. That isn't collapsed too far, but it's adequate to get back up.
Roger, we copy.
It's a pretty good little jump.
Buzz, this is Houston. F2, 1/160th second for shadow photography on the sequence camera.
Okay. I'm at the foot of the ladder. The LEM footbeds are only depressed in the surface about 1 or 2 inches, although the surface appears to be very, very fine-grained as you get close to it. It's almost like a powder. Ground mass is very fine. I'm going to step off the LEM now. That's one small step for man, one giant leap for mankind.
Since Armstrong and Aldrin walked on the moon, 10 others followed in their footsteps. Skylab was launched as the world's first space station. Americans and Russians shook hands during Apollo-Soyuz, and 63 shuttle missions have been launched from the Kennedy Space Center, including STS-65, which is orbiting the Earth tonight. Hundreds of men and women are responsible for these achievements, and this is their moment. This is Mission Control, Houston.